As Bob had said, it's good to spread the blame around, so thus I put some co-authors on there. Lisa was my summer student this summer, and she's mapping the Cheticamp Pluton, and both Sandra and I are co-supervising her. And instead of stealing most of the stuff out of Matt Tucker's thesis and some of his unpublished stuff, I threw his name on there to make it all sort of legal-like, so I don't get any crap from him. But who knows? Acknowledgements. Taylor Chu, which was Ron's student this summer. If you ever get his CV crossing your desk, hire this guy. He is excellent in the field, just to let you know. Travis McCarron, he's doing a PhD at a UNB on rocks immediately to the east of our area. And he's found some interesting stuff, and we've been sort of transferring data back and forth. Garth DeMont with a big M, because that's how you spell his last name. He has helped with some of the samples and some of the ideas with VMS deposits. And we actually talked Dr. Deanne Van Ruyen from the Cape Breton University to do some of the dating for us. So it's good to have some help on the ground. You don't have to do it yourself. James Bridgeland, who works with the park, he fast-tracked our collection permit for inside the park. And finally, Laurie's Motel, the breakfast buffet is to die for. But if you eat too much, you can't make it up the hills. The Cheticamp area. Well, for most of you who don't know, it's in northern part of Cape Breton in an area known as Ganderia. And Ganderia is a package of Neoproterozoic rocks that are unconformably and or in faulted contact with Cambrian to Ordovician volcanic arcs. And with those arcs are associated granitoid rocks and sedimentary rocks. And for those of you in the old terminology, Gander would be equivalent to exploits Gander trains in Newfoundland or the Central Mobile Belt. So we'll talk about Ganderia in Cape Breton Island. It consists of the Bredor terrane and the ASPY terrane. Bredor terrane's over here, and the ASPY's up there. Now the Bredor terrane, again, this side, is largely made up of Neoproterozoic metamorphic rocks, both high and low grade. The high grade rocks tend to be high temperature, low pressure, cordierite bearing, and the low pressure ones are just basically dirt, cordierite, and are chlorite bearing sort of slates and phyllites. And you have a suite of arc-related granitoid rocks, and these together are considered basement. So the granitoid rocks all range, they're expanded calc-alkaline types of rocks, from diorites right through to cyanogranites. This light doesn't stay on for too long, by the way. Now, the ASPY terrane, at least in Cape Breton Island, it can be divided into two parts, an eastern part and the western part, as shown there. The eastern part is basically a package of Ordovician, to Silurian metavolcanic and metasedimentary rocks, and they seem to have been metamorphosed in the late Silurian to early Devonian. There are also large areas of about 440 MA orthogneiss, very high grade, but the protoliths were still unsure of what they actually are. And all of this suite is intruded by abundant Silurian and Devonian plutons. And here's just a couple of rock shots. That's out Money Point. Those are the volcanic rocks. Cape North Group. Very coarse schists. I've often wondered if this just isn't a conglomerate that becomes schistose. The Cheticamp Lake gneiss you see here is a mixture of marble and amphibolite rocks, which are probably dikes or transposed diorites of some sort. The granitoids are quite similar. They're Siluro-Devonian, coarse grain, megacrystic in places, and again, they're easy to map in the field. The ASPY terrane, western part, late Neoproterozoic metavolcanic and metasedimentary rocks of the Jumping Brook metamorphic suite. And those are intruded by what we think are late Neoproterozoic plutonic rocks like the Cheticamp Pluton, and I'll come back to that a little later. Plus we have some minor Devonian plutonic rocks, and those are shown in the pale yellows in there. There's this picture of Grand Falaise, the Cheticamp Pluton, which is probably 550 million years old. We'll come back to that in a little more detail. So just a summary of Ganderia in Cape Breton Island. It's the most geologically complex terrain in Cape Breton Island. It forms from various tectonic settings. There's numerous economic mineral occurrences, which is very important. And various structural and metamorphic models have been sort of devised from various people working up there. Internal geological relations and regional correlations unclear. That's largely because of lack of mapping, sampling, and modern geochemical database. And because of this, there's uncertainties about the correlations with Ganderia, let's say, in Newfoundland and New Brunswick. The main reason all these are complex is because we have a lack of age control in the units, and hence a lack of age control in the timing of deformation, metamorphism, and mineralization. So finally, we'll get to the purpose of this talk. We picked the Cheticamp area for detailed mapping, geochemical and geochronological structural studies because, one, we do have a suite of previously collected samples from various theses done at Acadia. We have thin sections, a large geochem database exists for most of the area. There's a variety of igneous metamorphic rock types, which are all suitable for uranium-lead dating, and the area has probably the best known economic potential, in my opinion, in Cape Breton. And finally, what Dan Contact told me on the field trip, Tim Hortons is closing up there. A community without a Tim Hortons is dead. We need to do something. We need to do it fast. 20 people out of work. That's a lot of people out of work at Cheticamp. Plus, Cheticamp, the Tim Hortons was the only place you can access your government email. For some reason, none of the hotels, our security system just shuts you right down. You can't access, so yeah. Gonna miss it. Map units in the study area. Well, it consists of the jumping Brook metamorphic suite, which consists of various formations. The Stewart Brook formation is a new one, shown down here that Lisa and I defined this summer. Faribault Brook, shown in here. Barren Brook is sort of the darker yellow color. Dauphinee Brook is brown, and we get it up in there as well. There's Corny Brook, Fishing Cove river formations. Cheticamp Pluton, which is called 8F. You have a look at the map on I put that down on the bottom. If you look at the map, you have a better idea where the distribution of these units are. But the Cheticamp Pluton extends pretty well the whole length of that map. Very narrow belt. The George Brook formation, which is in there, died. It's just a bunch of amphibolites that are probably metamorphosed diorites, gabbros have been transposed. The Rocky Brook conglomerate down there, number 8, I have no idea what that is. The Marguerite Pluton is a nice Devonian Pluton down there. Fisher Brook formation shown in green, we'll talk about that a little later. Salmon Pool granite, it's up in there, it's another Devonian Pluton. The Carboniferous sedimentary rocks are all shown in shades of gray to the west there. These are the formations I'm going to talk about in more detail, largely because the other ones, the access is hard to get to. I'm old, I'm out of shape, and I don't want to lose another summer student. So perhaps next year we'll get to those ones further inland. So the Faribault Brook formation, shown in here, extends from Faribault Brook all the way down to Belcote Road. It appears to be the oldest and most extensive formation in the Jumping Brook metamorphic suite, but it is undated. Its minimum thickness, based on drill core, is about 180 meters, but you have to remember the stratigraphy is highly attenuated and transposed sub-horizontally, so there's a lot of deformation happening in here. We don't know what the basement is to the Faribault Brook. Hosts several copper, zinc, and lead mineral occurrences, Junction Falls, for instance, and Iron Cap. Here's a few rock shots. It consists mostly of volcanic or mafic metavolcanic rocks, as you see here. This is the first one is near Junction Falls, and basically it's sub-horizontal. Locally, there's nice pillows developed, and as you can see in thin section, they are quite metamorphosed. There's no real original volcanic textures left. The Barren Brook, Dauphinee Brook, and Stewart Brook formations, I basically grouped those guys together because they all appear to overlie the Faribault Brook. Although Stewart Brook formation to the south, we don't know, but based on lithology, we correlate it with Barren Brook and Dauphinee Brook. They're very similar. The minimum thickness, again, based on drill core, is about 50 to 300 meters, but again, the stratigraphy is so transposed, it was probably considerably thicker at the time. Dominantly metasedimentary, and what we discovered with Travis's work is there's a lot of zinc and arsenic in the sediments. And why is that important? Well, for him, as he's working on a metamorphic thesis, it expands the storolite field for metamorphism. So you get storolite at very low grades and storolite at very high grades, which is not supposed to happen. And based on some of the sedimentary features, it appears to be a turbiditic in nature. And again, it hosts a lot of copper, zinc, and lead mineral occurrences like Galena Mine and Korshak. And some more rock shots of the formations. They consist dominantly of slate, phyllite, and schist, with minor quartzite and rare crystal tuff. This particular slide shows some of the slates in there and a thick crystal tuff overlying it. What's also important is upstream from there, you have these layers that are a little more coarser grained, and they actually show sort of Buma sequence-like things. There's cross bedding, there's actually graded bedding in there. And finally, what a major characteristic of these units are these blue quartz eye metasandstones to pebble conglomerates, as you can see here. Now, we all know that blue quartz has this metaphysical kind of properties if you read the internet. And I'm here to tell you it doesn't work because I'm sicker than a dog right now. So somewhere it might work, but it doesn't work for me. Anyway, again, with these formations, there are rare quartz garnet muscovite schists. This is one out of the Galena mine. Huge garnet, it's up to 1 centimeter in size. And quartz, these have often been called porphyries, quartz garnet porphyries. But in thin section, I mean, these are spessartine garnets. It's a metamorphic rock. Maybe it's an altered, or metamorphosed altered rock. We don't know. We have to do some more work on it. So what are the ages out of the metamorphic suite? Well, the youngest uranium-lead detrital zircon age comes from 2 samples from the Dauphinee Brook formation, 546 and 551, so the late Neoproterozoic. This is from Lynn's work. But these are less than ideal ages. This is done the old style. And in fact, I think you only had 4 zircons for one of them, and they're very bad. Another uranium-lead age of 420 was from that rhyolite porphyry at Galena Mine. Well, in fact, it wasn't from the porphyry. It was from 100 meters downstream in one of those blue quartzite sandstones. And that one is a very bad age. There's only 4 fractions in there. The common lead errors go right off the diagram, so I wouldn't even try to interpret that age as really meaning anything. So we'll jump into the Cheticamp Pluton. Compositionally expanded, diorite to cyanite. There's diorite here, that's unit A, but I can't see. You have to go in the map out there to see where unit A is. It's to the south. B is dominantly a tonalite. C and D, we're getting to some nice granodiorites. The only difference is the texture. E is a muscovite-bearing, coarse-grained to megacrystic granite found right in the center where the pink is in the Pluton. And that whole suite is intruded by these late cyanogranites, F. There's a uranium-lead age of 550, plus or minus 8 from the muscovite-bearing unit of that. And again, that's old-style date. You take 5 grams of zircon, pour it in the machine, and out comes a number. That should be redated. However, the muscovite age out of that same sample came out at 445, so it probably works in this case. The contacts with the original The contacts were probably originally intrusive into the Jumping Brook metamorphic suite, but now they're dominantly faults, and it's overlain by the Devonian Fissett Brook Formation, which we'll see a little later. There you go, Fissett Brook. Basalts and rhyolite flows, minor sedimentary rocks. The uranium lead ages are Devonian, and they confirm the late Devonian fossil age. And these are good ages. They're from Greg Dunning's lab, and they're well done, more recent. Here we can see, this is just at the unconformity. There's a granite just off the side, and you see some nice layering in there, and some pillow-type structures in some of the basalts down there. Now we're going to get confused, two hands here. Fissett Brook Formation, typically faulted contacts with the older units, and this is Grand Falaise, the top one, and if you go to that site, you can actually see the granite thrust over amygdaloidal basalts right there. Further along the road, the Grand Falaise here, that's an unconformity. If you dare climb up that slope and look at that, that's a good basal conglomerate of the Fissett Brook with rhyolite flows sitting unconformably on very jagged, weathered Cheticamp Pluton granitoid rocks. Remember, you need a collection permit to get in there. You can walk this talus slope and see all those rock types up there. So the summary of the age constraints, other than the Devonian Fissett Brook Formation, there's very little good age control in any of the units in the Cheticamp area. The uranium lead ages from the Jumping Brook metamorphic suite suggest it's late Neoproterozoic or younger. That's the best we can do. The uranium lead zircon age from the muscovite bearing Cheticamp Pluton, which is unit E, together with its associated argon age, suggests a late Neoproterozoic age, but that's only for that phase of the Pluton. There's other parts of that Pluton that look entirely different and could be either older or younger. So modern precise uranium lead ages are critical to deciphering the geological history of the area. So we'll jump into the geochemistry. Geochemistry finally is straightforward. Now, based on the normative plot on the bottom here, the Cheticamp Pluton ranges from diorite to granodiorite to alkali feldspar granite, and combined with the AFM diagram on top, it shows a nice calc-silicate trend. On the tectonic setting diagram down the bottom here, all the samples plot in the volcanic arc field, well-behaved granite, surprisingly for all the different units. Now, if we look at the geochemistry of the Jumping Brook metamorphic volcanic suite, or metamorphic suite, the volcanic units, mostly the Jumping Brook, on the ZRTI plot versus silica, you see that most of them are subalkaline and plot in the basaltic field, whereas the more rhyolitic ones, of course, are subalkaline and plot in the rhyolite field, as they should. On the other diagram here, the mafic samples plot in the arc basalt, but because they're up in this area, they're the tholeiitic arc basalt and really close to the morb. Geochemistry, again, on the AFM diagram, clearly tholeiitic in nature, but what the real kicker was, this is what Matt's contribution out of his thesis. These are replots out of the Faribault Brook metavolcanic rocks, and they're almost identical. Beautiful. With one sample that has sort of a negative europium anomaly. So, a summary of the geochemistry, mafic samples, typical of mid-ocean ridge basalts with derivation from apparent mega with a depleted mantle source. The pillow character of the basalts, taken together with the turbiditic character of the associated sedimentary rocks, doesn't suggest a mid-ocean ridge, but more of a back arc basin. The Cheticamp Pluton has arc-like characteristic and may represent the adjacent late Neoproterozoic continental margin magmatic arc for those volcanic rocks. And overall, the chemical data are consistent with a co-magmatic relationship among all the igneous units in the study area, but they do not necessarily, they don't have to be related. Mineralization. Now, I'm not an economic geologist, that's why we have one on staff now, so he can correct me when I'm wrong here. Several years prior to 1865, copper was actually mined south of Pillar Rock in what they called trap, which is actually the basalt of the Fisset Brook. And barite in foot-wide veins to the northeast along the coast was actually mined. You can't find the copper mine anymore. They put a road over the top, but the old trenches in the barite still exists. Galena was found in schist in the lower part of Faribault Brook in 1897, and since then the region has been explored for its numerous base metal occurrences and has locally been mined. There's the Galena mine, the Mountaintop, and Iron Cap were, I think, the first three that were actually mined and adits put in. Mineralization in the Cheticamp area, two possible episodes. The main one, of course, is in the Jumping Brook Metamorphic Suite, and it appears to have similarities to VMS deposits, which is probably not a surprise to most people in here. There also seems to be a set of late synchronous copper, lead, gold-bearing quartz veins. We're still waiting for some of the analysis back from there. But what we've discovered are several new Devonian copper and barite plus or minus silver occurrences that are related with Fisset Brook and the Cheticamp Pluton, but tend to be along fracture zones in those units. VMS mineralization, again, it appears to be stratabound, just some evidence that it is VMS. Ore is deformed and metamorphosed. As you can see, this is a sample from Galena Mine, and nice pods, elongated pods of galena and sphalerite. And this is a sample that Garth gave me, and it shows a nice folded set of sphalerite, galena, and chalcopyrite in the core, and there's just Galena Mine. And there's a thin section of this sample showing a nice garnet with some biotite and chlorite. So again, these things are strongly metamorphosed. These later quartz veins, this is the mountaintop, and you can see they're always strongly boudinaged, except for this one that, of course, was the exception to every rule, that cross-cuts the deformation. But the margins of these host pyrite, chalcopyrite, galena, and possibly gold. But it's in the margins of the country rock, not the quartz vein itself. And I think these are probably related to the VMS, late synchronous with it. Copper, barite, silver, shear, and vein-related mineralization. The barite and copper carbonate veins cut the Cheticamp Pluton and Fisset Brook Formation. Copper also occurs in faults, mafic dikes in the basal part of the Fisset Brook up in here. And you can find beautiful samples in the talus slopes down here. And that is one of these quartz veins up in here that has chalcopyrite rimmed by malachite. And the barite, this is in the park, and that's where you cross the contact from the Jumping Brook into the Cheticamp Pluton. And on the highway there's about a foot wide pure barite with silver vein cutting there. If you stop quickly and sample before the guys get you, good luck. But the old trenches are just up behind here and all along the coast. And if you walk out to the point, all of these veins you see here that you think are carbonate are all barite. And sadly, as you see, most are in the park. So what we're doing now is trying to see how far south we can trace these out of the park, and it seems we've had some luck so far. And the old copper mine, it's just around the corner. As you go around that corner and there's a hiking trail, it used to be right there. And you can still see some of the stuff where it's collapsed in. Again, sneak in there, cut some samples, but you didn't hear that from me. Regional correlations. Well, if the Jumping Brook Metamorphic Suite actually does turn out to be late Neoproterozoic, then it would correlate with the Brookville or the New River terrain in southern New Brunswick. That's probably not good. There's no VMS deposits there. It's not worth looking. In Newfoundland, it would correlate greatly with the Burnt Pond deposit here, which has 563 volcanic rocks and associated plutonic rocks. That would be a great place to look. If the Jumping Brook is younger, let's say Cambrian, and we could relate it to the Penobscot volcanic massive sulfide, that is shown in the yellow here, then there are several possible deposits that it could be correlated with. And I was just at the Newfoundland open house, and they were talking about Long Lake and Long Lake VMS, and it sounded like the spitting image to the stuff in Faribault Brook. Highly transposed, metamorphosed, mineralization in long elongated pods. And their solution was to do high-resolution magnetic survey to define where these things are, and from that have defined several new targets that they've been drilling. So they're happy with that. If, however, it becomes even younger and Ordovician, then it's related to the Popologan Victoria Arc or the Tetagush Exploits VMS deposit. Then everything's wide open. Then it might be related to the Bathurst camp. I think there's a lot of smoke in here that we have to look at closer. So summary. The Cheticamp Faribault Brook area is well within Gander. It has very close similarities with Newfoundland and New Brunswick in terms of their geology. Hence, they'll have similar economic mineral potential. But in spite of the fact the Cheticamp Faribault Brook area continues to be underexplored, we need to better promote the area, but we need more precise uranium-lead ages to confirm the similarities and maybe make up a nice package to sell to companies to come and explore here in Nova Scotia. And there may still be hope for those 20 employees. Maybe we can put them into a mine or something. The only warning you get for coyotes that are in the park, but once you're out of the park, they're still coyotes. You just don't get warned about them. Any questions? And if you don't have any questions, we can talk at the poster. Thank you.